Hi students, welcome to Easy BTech channel. Please like, share and subscribe our Easy BTech channel. And today in this session I am going to explain about the last mean value theorem, that is Cauchy's mean value theorem. The Cauchy's mean value theorem statement. So if f maps a to b tends to R and G maps a comma b tends to R such that the first condition f and g are continuous, f and g are continuous on a comma b, and second condition f and g are derivable, f and g are derivable on open intervals of a comma b. Third condition, g dash of x is not equal to 0, then there exists at least one element C belongs to a comma b such that the condition, students, f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. This is the main condition of Cauchy's mean value theorem. So the Cauchy's mean value theorem states that choosing the two functions f and g here, the first condition, both functions are continuous, both functions are derivable, and the third condition, g dash of x is not equal to 0, then there exists at least one element C belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. The problems related to Cauchy's mean value theorem. So verify Cauchy's mean value theorem. Verify Cauchy's mean value theorem for the functions for f of x is equal to sin x and g of x is equal to cos x in the interval 0 comma pi by 2. So okay, solution. So at first it was given that f of x is equal to sin x and g of x is equal to cos x. So what is the first condition in Cauchy's mean value theorem? Verifying f of x and g of x are continuous or not. Of course the given functions are trigonometric functions, so you can say that f of x and g of x are continuous on closer intervals of a comma b. Coming to the second one, so derivable condition, then doing the differentiation of f of x. Here f of x given as a sin x differentiation is cos x, and g dash x, g of x in the question it was given that it is cos x, then differentiation is minus sin x. So hence you can say that here f of x and g of x are derivable on open intervals of a comma b. And what is the third condition, students? Yeah, of course, third condition is g dash of x is minus sin x, which is not equal to 0. So hence the given two functions satisfying the three conditions. What are they? First one is the continuous, second one is the derivable, and third one is the g dash of x is not equal to 0. So then there exists the condition of Cauchy's mean value theorem, then there exists at least one element C belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So here the values of a and b are, a is 0 and b is pi by 2, which was given in the question. Between the interval 0 to pi by 2 was given in the question. So now finding the all corresponding values. So using the second condition, f dash of c. So f dash of c is nothing but here cos c, and g dash of c is minus sin c, and finding the all values, students. So here in the question it was given that f of x is sin x and g of x value is cos x. Okay, yeah, at first we are finding f of a, that means f of 0, that means sin 0, that is equal to 0. So next one, f of b, that is f of pi by 2, that is sin pi by 2, that is equal to 1. Coming to the g values, g of a, that means g of 0, that means cos 0 is equal to 1, and g of b, g of pi by 2, cos pi by 2 is equal to 0. So now what is the condition? Cauchy's mean value theorem condition, f dash of c here. So what is the value of f dash of c? F dash of c is cos c by g dash of c. G dash of c value is minus sin c and is equal to f of b. So here see here, that is what is the value of f of b? F of b is 1 and minus the value of f of a is 0 divided by g of b. What is the value of g of b? That is 0 minus g of a. G of a is 1. Simply substituting all values. Of course, we know that cos by sin is nothing but cot, then minus cot c is equal to minus 1. So minus 1 will be cancelled. Then c is equal to cot inverse 1. That is c is equal to pi by 4. So our intervals are given in the question as 0 to pi by 2. Of course the pi by 4 is between the values of 0 to pi by 2 only. So hence you can say that here, hence Cauchy's mean value theorem is verified. Cauchy's mean value theorem is verified. Yeah, the one more question related to the same topic, Cauchy's mean value theorem. Verify Cauchy's mean value theorem for f of x is equal to root x and g of x is equal to 1 by root x in the interval a comma b. Yeah, and the solution. So it was given that in the question, given f of x is root x and g of x is 1 by root x. Yeah, coming to the first condition of Cauchy's theorem. Cauchy's theorem first condition is verifying the given f of x and g of x are continuous or not. So f of x and g of x are continuous on interval, closed intervals of a comma b. Coming to the derivability, f dash of x, then root x differentiation is 1 by 2 root x, and g dash of x, if you are doing the differentiation, you will get the value as minus 1 by 2x root x here. The intervals here, of course the derivability condition is satisfied. F of x and g of x are derivable on open intervals of a comma b. Third condition, g dash of x minus 1 by 2x root x, which is not equal to 0. Yeah students, now it is continuous condition is satisfying, derivable condition is satisfying, third condition is also satisfying, then there exists at least one element C belongs to open intervals of a comma b such that, so what is the condition? Cauchy's condition, f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Cauchy's theorem, main condition. Yeah, now finding all values. F dash c, g dash of c, f of b, f of a, and g of b, g of a. So here the value of a is nothing but a and b is nothing but b only. Okay, finding the values. So f of x is root x, then f of a, that is root a, and f of b, that is root b, and g of x is 1 by root x, g of a is 1 by root a, and g of b is 1 by root b. Using the second condition, the values of f dash of c. F dash of c is nothing but 1 by 2 root c, and the value of g dash of c is minus 1 by 2c root c. Okay, using the second condition only we find the values of f dash c and g dash of c here. Now substituting the all values. So first value is f dash of c, that means 1 by 2 root c divided by g dash minus 1 by 2c root c, and is equal to f of b. F of b is root b minus f of a, that is root a, and divided by g of b. G of b is 1 by root b minus g of a 1 by root a. Okay, these are the two values here, f dash of c and g dash of c values. So substitution is over. Now doing the simplification of this one. Minus 1 by 2 root c, and into doing the reciprocal 2c root c by 1 root b minus root a by. So now I am writing the denominator simplification here, 1 by root b minus 1 by root a. So the LCM, that means root of AB, then root A minus root B is a simplification. So I am writing here root A minus root B by root of A B. Yeah, now here 2 will be cancelled, and again root C also will be cancelled. So the remaining term on LHS is only minus C, and RHS root B minus root A into root AB by root A minus root B. Yeah, okay. So see here, minus root B minus root A is there here, and here in the denominator root A minus root B is there. Then making minus common here, then root A minus root B into root AB divided by root A minus root B. Okay, so now these two terms will be cancelled, and here minus also will be cancelled. So the remaining term C is equal to root AB. So which is belongs to the A comma B, because the intervals consisting A and B. So if you are doing the product of any two numbers and finding the root of the two numbers, then compulsory that value should be belongs to the given intervals only. So hence CMVT, Cauchy's mean value theorem, verified. This is about the Cauchy's mean value theorem. Students, please like, share and subscribe our Easy BTech channel. Coming to the one more question. Verify Cauchy's mean value theorem for f of x is equal to e power x and g of x is equal to e power minus x in the interval a comma b. Coming to the solution, the solution part. So it was given that f of x value is e power x and g of x is e power minus x. The same as usual conditions, given f and g are continuous exponential functions. So continuous on closed intervals of a comma b, and second one f comma g are derivable on a comma b. Third one, so doing the derivable condition, f dash of x is e power x and g dash of x is minus e power minus x. The third condition, g dash of x, that is e minus e power minus x, which is not equal to 0, then there exists at least one element c belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Now here the values of a is a only and b is b only. So let me find out all values, students. So f of x is e power x, f of a is e power a, f of b is e power b. Okay. G of x given in the question e power minus x, g of a e power minus a, g of b e power minus b. Okay. Now the LHS part values. So f dash of c, f dash of x is e power x, then f dash of c is e power c, and g dash of c. So g dash of x is minus e power minus x, then minus e power minus c. Substitute all values. F dash of c value is e power c by g dash of c minus e power minus c is equal to f of b e power b minus e power a by g of b e power minus b minus e power minus a. Substituting all corresponding values in Cauchy's mean value theorem main formula. Okay, now doing the simple simplifications. Minus e power c into e power c, students, because here 1 by e power minus c is there. So if it comes to the numerator, power value becomes as a plus here, that is equal to e power b e power a. So let me do the denominator simplification here. E power minus b e power minus a. So e power minus b is 1 by e power b minus e power a. Okay, students. Now finding the LCM here, e power b into e power a is LCM. Then numerator term e power a minus e power b. Okay, I hope you understood here. Then substituting the value directly, e power a minus e power b by e power a plus b, because the base is equal here, we may adding exponential term a plus b. Okay, yeah, here minus e power 2c is equal to e power b minus e power a divided by e power a minus e power b into e power a plus b. So if you are making minus common here in numerator, e power a minus e power b divided by e power a minus e power b into e power a plus b. And now these both terms will be cancelled and this minus also will be cancelled. The remaining term e power 2c is equal to e power a plus b. So here using the exponential formulas. So the exponential formula for this one is, if bases are equal, then exponentials are also equal. Then 2c is equal to a plus b, C is equal to A plus B by 2, which is belongs to the A comma B. Because if intervals consisting as A comma B, if you may choose any two values on that intervals and adding that values and doing by 2, then compulsory that value belongs to the given intervals only. So hence we can say that here CMVT, Cauchy's mean value theorem, is verified. So that's about the Cauchy's mean value theorem. Okay. So now here, so the mean value theorem, students, mean value theorems we discussed in our last sections. So there are three types are there in mean values theorem. So the number one is Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem. Okay. In these three mean values theorems, the first two conditions are as it is, same conditions, that is continuous on A comma B and derivable on A comma B. Derivable on A comma B. For Lagrange's also the same conditions, continuous and the second one is derivable. Okay, students. And CMVT, that means Cauchy's mean value theorem, is also the same conditions, continuous on closed intervals of A comma B and derivable on open intervals of A comma B. So here also closed interval and open interval. So in Rolle's theorem, the third condition is f of A is equal to f of B, and in Cauchy's mean value theorem, third condition is g dash of x is not equal to 0. And here if any function satisfying these three conditions, the main condition is f dash of c is equal to 0. And in LMVT, and that means Lagrange's mean value theorem, the main condition f dash of c is equal to f of b minus f of a by b minus a. And in Cauchy's mean value theorem, the main condition f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So if satisfying these three conditions, existence of an element, that is c belongs to a comma b here, c belongs to a comma b and c belongs to a comma. That's enough the these three theorems. First two conditions as it is. Rolle's theorem, f dash c is equal to 0. LMVT, f of b minus f of a by b minus a is equal to f dash of c. And CMVT, Cauchy's mean value theorem, f dash of c by g dash of c is f of b minus f of a by g of b minus g of a. Yeah, from this session, mean values theorems topic is completed. And the next session, we will discuss about the one more topic. Thank you for watching. Please like, share and subscribe our Easy BTech channel.